in this session, in this lecture, we are going to be discuss loop optimization, peephole optimization, flow graphs, data flow analysis of flow graphs. So flow graphs and data flow analysis of flow graphs already we discussed in the previous session with the help of basic blocks. Okay, in this session we will discuss only the loop optimization, peephole optimization, and once again we are seeing in-depth principal source of optimization. Okay, these three topics are look like similar. So first we will discuss the loop optimization. So loop optimization. First question, when we are talking about the loop optimization, the first question is, what is the need for us to do the loop optimization? That is the first question. My dear, the simple rule, when you are doing the optimization, if you are do the optimization for ordinary instruction, only that instruction, for example, I will consider an example like this one. If maybe in this block we are executing in sequence, like it is the instruction 1 and so on, we have some instructions like instruction n. If the optimization can be achieved at jth instruction, okay, assume these are the normal instructions, nothing but not considering under loop. If you are optimizing this instruction, maybe when you are executing this instruction maybe takes the 2 clock pulses. When you are doing the optimization, maybe it can be reduced into the 1. How many clock pulses are you saving for such type of optimization? Only 1 clock pulse. My dear, focus it. If it is the ordinary instruction, once again I am repeating, if it is the ordinary instruction, nothing but it is not under any part of loop. Before doing optimization, that instruction needs the 2 clock cycles to execute the instruction. After performing code optimization, the instruction now it takes the only 1 clock pulse. Now how many clock pulses are you saving? Only 1. So this is a case when you are talking about the ordinary. Now think, we are talking about the loop. So this is a loop. Maybe our loop can be run 10 times. So I'm changing pen color. Maybe it is not too good to visualize. Okay. So now observe this part. Nothing but this is the loop for us. This loop can be executing 10 times. We are talking about the ith instruction. Before optimizing, it takes the 2 clock pulses. When you are doing the optimization, now it takes the 1 clock pulse. Now how many clock pulses are you saved? If you're talking about the ordinary instruction, it is the only one. But this instruction is not an ordinary, it is under the part of this loop. This loop will executing 10 times. When you are optimizing this instruction, for 1 time 1 clock pulse, for 10 times you are saving the 10 clock pulses. So that's why all the programming languages, nothing but under all the programming languages, when you are designed a compiler, the compiler must be mainly focusing loop optimization concept. The reason is, with the help of optimization only, we are reducing the more number of clock pulses. In other words, we are executing our program very faster. So that's why loop optimization becomes necessary for code optimization. Now, what are the different techniques we are following under loop optimization? We have the three different techniques, my dear. First one is the invariant code, second one is the index analysis, and third one is the strength reduction. First, I will give the basic of what is invariant, what is the induction, what is the strength, then we will discuss with example of each and every one. So, invariant code in the sense, if this is our loop, in this loop, if I am saying these two instructions, nothing but the code, one fragment, this fragment of the code having same value for each and every time iteration. At each and every time when you are iterating, now we can assuming your loop may be executing 15 times. Out of these 15 times, these two instructions code does not change at that moment. Those two instructions code in technically called invariant code. You got my point? So I am repeating once again. If it is your loop, in this loop you have so many instructions. Some of the instructions, nothing but instruction I and instruction I plus 1. These two instructions, nothing but two instructions in the sense, these two having certain code. So that code always having the same content for or at each iteration. For all the iterations, those two instructions code does not change. At that moment, that code in technically called invariant code. Okay. Next one, induction analysis or induction variable. When you are talking about the invariant code, that code or in that code, if unchanged data can be assigned to any variable. Previously we are talking about the only code, my dear. But when you are talking about the induction variable, that code is assigned to any variable. Maybe we are assigning that code to some variable or some set of variables. That variable or some those set of variables technically called induction variable. We will see with an example also. When you are good at the invariant, induction variable is or induction analysis is simple. And strength of reduction. Strength of reduction in the sense, now we can assume already you studied the concept of computer organization, particularly the topic name under computer organization or CAO, computer architecture. Micro control program as well as the nothing but control memory. The topic name is control memory. Now we can assume you have the two operations. One is the multiplication and one more thing is the plus. My dear, it is not required to study the computer organization in general. So think how you are applying the multiplication or achieve the multiplication operation, and how you are achieve the plus operation. Now we can assume x plus y. How many bits are there under x, and how many bits are there under y? Those number of bits, these number of bits, simply we are doing the addition. That addition may be the serial or parallel based on our architecture. We are getting the result. That is the addition. Now observe, when you're talking about the multiplication, like x into y, how you are achieving the multiplication? X into y, in the sense y times we are added the x, that is the result of x into y. So in general, or for our convenience, I am using the some numeric example like 10 into 5. What is that meaning? 10 added 5 times. 10, 10, 10, 10, 10, nothing but 10, 10, 10, 10, 10, 5 times. When you are adding the 10 5 times, then only you are getting the 10 into 5 result. Nothing but how many times the operations are you perform. For x plus y, your operations may be the n, or your clock cycles may be the n. How many times you are spending these clock cycles? And also, when you are doing the order, nothing but addition, we know we have the full order only. Half order, full order. Full order is working for only 3 inputs, nothing but one full order required for these two, nothing but we are getting partial result. For that partial result with this one full order, this partial result with this, and this one with this. I think these are all extra clock pulses we required. So that's why if you are changing from multiplication to the plus, that is also the code optimization. Nothing but that is also you are reducing the clock cycles. So that's why if possible, strength is reduced. Strength in the sense, already we know the number of clock pulses required for the multiplication is more than the plus. So the number of clock cycles is reduced. That is in technically called strength reduction. And all we are good at the one more concept, shift operations, shift logical operations, or logical shift operations. So we have the shift left and shift right. I am not talking in depth. So what is the meaning of shift left? When we have the register, within that register, each and every bit can be shifted towards left. Let us assume the original value is the n. If you are shifting k number of bits, now the resultant of the after k number of shift left, the value must be the n into 2 power k. We know it. If it is 10, what is the 10 equivalent binary code? 1 0 1 0. If you are doing the shift left, nothing but 1 0 1 0. Under shift left, our LSB always 0. Now what is the value of 1 0 1 0 0? It is the 20. Nothing but 10 into 2 power, how many bits are you shift lefted? 1. So that's why 2 power 1 is the 2, 10 into 20. In the same way, it is also working for the shift right. Under shift right, the number can be divisible by 2 power, how many bits are you shifted towards right. Okay, that is also strength reduction. So now we will see each and every optimization technique with an example. First, invariant code. So now observe, this is the actual code before optimizing. For I equal to 1 to 10, j equal to 22 by 7, write nothing but print the value of I by j. If you are clearly observe, j equal 22 by 7 inside the loop. When it is inside the loop, how many times we are repeating? 10 times. Those 10 times are those 10 times of iterations. Your j value does not change. At that moment, better to move that j value within the statement, within the loop to outside the loop. Sometimes it is also called code motion. Be careful. Better to know this also. Code motion. The name itself. Code can be moved from one basic block to another basic block. Or in other words, code can be moved within the loop to outside of the loop. Nothing but code can be moving from one position to another position, that is technically called code motion or code moving. In sometimes for the competitive exams it is also important. Code motion. Now observe, when you are moving that instruction outside of the loop, now the code becoming a j equal to 22 by 7. Now observe, if j equal to 22 by 7, for the calculating, if you required 4 clock cycles, CPU cycles, 10 times 10 into 4, 40 clock cycles we required for only this second instruction. When you are moving outside of the loop, we required for the only 4 clock cycles for the statement 1, nothing but j equal 22 by 7, and we are not repeating that statement within the loop. So previously we required, before code optimization we required the totally 4 into 10 40 clock cycles. Now we need only 4 cycles. You are reducing 36 clock cycles. Okay, it is a invariant code. Best example. What is the meaning of invariant code? A statement or a code within the loop having the same value at each and every iteration. Now observe, j equal 22 by 7. The statement always having the same value. So that's why j equal to 22 by 7 statement or code instructions are called invariant code or invariant statements. Now we will see the second technique example, nothing but index analysis. Now observe, you are writing the function copying from one array to another array. Nothing but all the B array elements are copied into the A array. That's your target. That's your aim when you are designing this code. Now observe. Maybe I am beginner. I think one variable required to the loop. Nothing but all the elements. If my this is a array and this is B array, A array size and B array size. I am copying all the B elements. If B array having 100 elements, I am repeatedly copied first element, then second element, and so on, and so on. 100th element copied from B to A. Nothing but I am repeating 100 times. For the repetition, I am using the one variable, that is the I1, and to pointing the BRA indexing, I am using the one more indexing variable I3. This is a source copied from B. For B array I am using the indexing variable 3. In the same way, for the A array I am using the indexing variable I2. How many indexing variables totally I am using? 3. One for the B array, one more for the A array, and one more for the how many elements I have, those number of times I am copied. Nothing but for my repetition. Now observe. So when you have such type of code, if you are optimizing properly, not required to maintain the A and B array indexes. Now observe. Here all the three variables are initialized with a 0. Then based on my indexing size or array size, I am repeating the process. When I am not required to use I2 and I3, simply I am writing I1 can be initialized with 0, I1 less than size. Every time I am increasing my I1, simply A of I1 is followed with B of I1. Here I am saving clock cycles to assign the I2 value, I3 value, and clock cycles for the increment of I2, I3, and memory for to hold the I2 and I3 also. Here optimizing with respect of memory as well as the CPU cycles. So this is our second technique. First one is the invariant code. Invariant code in the sense a code throughout loop iterations having the same value. Induction variable or induction analysis in the sense, if any invariant code is there, that invariant code can be assigned to any variable. That variable is technically called induction variable. And third one, strength reduction. Nothing but a operation which takes the more number of clock cycles is reducing to, if possible only we are applying it, reducing to less number of CPU cycles. Now observe. So this is our code. This is our condition, nothing but while, simple while loop, 10 times. Maybe our initial value of I you can assuming as 1, 1. So I less than 10, okay, go set j equal to clearly observe 3 into I, nothing but 3 plus 1. What is our j value? 4. So better I am changing my j equal to 4. Now a of j equals to a of j minus 2, nothing but I am talking about my indexing value can be reduced by 2. Next I am increasing the I value with the 2, nothing but every time increase by 2. Previous my I value is 1, now it is the 3, I equal to 3. Next time I will do 3 into 3 plus 1, nothing but when I equal to 1 your j value is 4, when I equal to 3 your j value is 10. Now once again your I value can be increased, nothing but becoming as 5, and your j value 3 into 5, 15 plus 1, nothing but 60, like and so on. Now already we discussed, multiplication always takes the more cycles than the addition. If you are changing this code in form of additions, your CPU cycles also are reduced. Now observe. Here I am creating the new variable s equal to 3 into I plus 1. So 3 into I plus 1 I am computing only once. I am not repeating 3 into I plus 1 throughout the loop. Previously j equal to 3 into I plus 1 within the loop. How many times your condition true, or how many times we are repeating that loop, those number of times you are doing the multiplication. Now that statement multiplication I am moving outside of the loop, nothing but by applying the code motion like s equal to 3 into I plus 1. Now the same I value, my j can be assigned with my created temporary variable or created variable is j equal to is. Now this is the same step and this is the same. Now observe, what is the difference of this j value? Initially 4, and second case 10, third case 16, and next case 7 into 3, 21 plus 1. Next case it is the 22. Nothing but every time it has a difference of 6. So previous j value can be added with 6. Now we are getting the new value. So that's why. Previously, what is the value I am getting? That s value can be added with a 6. If you are not replacing such type of instructions previously, always you are spending the multiplication CPU cycles. Now we are taking the only addition clock cycles, CPU cycles. And here some of the members are getting certain doubt. Definitely my dear, good, your doubt is 100% valid. What is your doubt? Sir, CPU cycles are reduced. Good, CPU cycles are reduced. What about memory? Previously there is no variable s, but I am creating the s. When I am creating, I must be allocate the space for it. My dear, we know according to our computer organization and operating systems, CPU utilization is more important than the space utilization. So that's why when if you are focusing with respect of time, you must be vote for this. So this is the thought technique method, strength reduction. Okay, what is the first one? Invariant code. Second one, induction analysis or induction variable, and third one is strength reduction. Okay, this is about the loop optimization. Now we are moving our second topic, that is the peephole optimization. So peephole optimization in the sense simple, my dear. When you are interested to apply the optimization method, it is not possible to apply the optimization method for entire source code or entire implement code form. That's why we want to be apply that code optimization methods for certain basic block or certain segment or a certain group of statements. So that is the meaning of peephole. Peephole in the sense you can consider your convenient what you have the capability to handle it. You can consider based on capability. Okay, about this peephole optimization, it is a very simple method but a very effective technique. When you are applying the peephole optimization, your intermediate code form as well as the target program must be optimized. Optimized in the sense your performance is improved. Performance in the sense CPU cycles takes very less. In other words, faster execution. That means performance improves, systems throughput value increasing, and also sometimes it takes the more less memory compared to the before code optimization. And also when you are applying the people optimization, your number of instructions are also possible to be reduced. Previously, before optimizing your code having the n number of instructions, but when you are applying the people code optimization, your resultant optimized code must be getting less than n number of instructions. Now, what are the methods or characteristics we are going to be applied under people optimization in the sense? First one, redundant instruction elimination. Redundant in the sense duplicate, flow of control information, algebraic simplifications, use of mission idioms. We will discuss one by one with examples. And along that, so many are there, but I listed here only 4. But we will see more than 4 also. Constant folding, nothing but the redundancy. Actually, it is not the meaning of redundancy, but constant. Now we can assume in our code x equal to 32, x equal to x plus 32. What is that meaning? Simple. What is the value we are assigned for the x? Now that value can be doubled it. Not required to once again initialize x equal to 32. Directly you can write the x equal to 64. So this is the simple. Nothing but what is the constant is there. Those are all constants are going to be replaced with its value. What is our constant? X. X is the numeric constant. What is that value having? 32. So we are removing this constant, that is in technically called constant folding. What is the constant we have? We are not interested to see it is a variable. We are interested to see it is a value. So that's why 32 plus 32 we are getting as a 64. And second one, unreachable code. What is the method of unreachable code in the sense? Now observe. In sometimes we are using the conditional statements, if, else, if and so on else. Sometimes based on our input data, some conditions may not be met. That is the unreachable code. For example, if you are writing if a some statements, then else some statements, your a value is always not equal to 0 when you are giving your data input. You never reach the else case, that is the unreachable code. Now observe this one. Go to L2, x equal to x plus 1. There is no L2, there is no label L2. When there is no label L2, we never reach that label, that is the unreachable code. So don't write such type of conditional statements. When you are writing the conditional statements, be careful whether all the cases are reachable or not. And this one, flow of control optimization, third one. Now observe, go to L1. Under L1 you are writing once again go to L2. Nothing but in our childhood, all we are playing the trick. When we buy a textbook, under by default what we are going to be write? We are going to be write our name first. If you are a good student, you are writing the name on the first paper. If you are some funny guy, simple, we are writing, if you need to know my name, refer the page 10. Under page 10 once again we are writing, if you are interested to find my name, refer the 100 page, and so on. Finally you are giving your name. In the same way, flow of control. Go to of L1. So you are reached the label 1. Under label 1, without writing anything, simply you are saying go to L2. So you are once again you go to the level 2. So instead of writing these things, simply you can write go to L2. So there is no need of writing the L. So this is the third one. First one is the constant folding, second one is the unreachable code, and third one is the flow of control optimization. And fourth one, algebraic simplifications. Algebraic simplifications in the sense, already we know, like identity rule. Summation identity is the 0, multiplication identity is the 1. In your code, if you are writing like x equal to x plus 0, not required to write it. Simply you are assigning the same value to the same variable. Previous value, once again you are assigned for the same variable. So such type of instructions don't write it. That is also the optimizing. And dead code. Now observe. In your code, sometimes you are assigned certain value to some variables. That variable is never used in your code. At that moment we are getting a warning message in generally all the compilers gives. Unnecessarily allocated the space for the variable, never use it in your program, in your source code. So nothing but what is the value you are assigned for that variable, having its value, but without uses of that variable, our code terminating, nothing but that variable in technically called dead code. So don't write such type of things. In the same way, already we discussed this with strength reduction or reduction in strength. When you are going to be write x equal to x into 2, better to write x can be shift left with the 1 bit. If x equal to x into 4, better to write x can be shift left with the 2. Like, so this is about the Peephole optimization. Okay, thank you.